We're going to be taking a little break from evaluating integrals and all of those different integral tricks, and we're going to go back to derivatives for just a little bit to something that's called L'Hopital's rule. At the end of this lesson, you'll be able to apply L'Hopital's rule to find limits that result in an indeterminate form. All right, so we're going to jump right in and look at what L'Hopital's rule does. We did, when we were in Calc AB, we were finding the limit as x approaches some number. It could have been infinity, it could have been 0, it could have been 1, and we ended up, we'll just be dealing with if I have a function divided by another function. And we sometimes, when we found that, we ended up getting 0 over 0. And so when we got 0 over 0, we usually looked for a different trick because I said that wasn't a limit. It is actually something that's called indeterminate. We can't decide what the limit is. It doesn't mean it doesn't exist. We just don't know what the limit is. So I usually had to do a cancellation technique, or we did multiply by the conjugate, or we simply plugged things in. So we just had some different tricks that we could use. L'Hopital's rule is going to help us not have to know those tricks. We'll just automatically, if I get something that's indeterminate, I'll get to use L'Hopital's rule. Another indeterminate form is going to be if the limit is equal to infinity over infinity. And once again, these two indeterminate forms doesn't mean that I don't have a limit. It just means I can't simply plug things into my value for c. So what we're going to do is something that's called L'Hopital's rule. If the limit as x approaches c of f of x divided by g of x is indeterminate, okay, then this is L'Hopital's rule. It says the limit as x approaches c of f of x over g of x is the same thing as the limit as x approaches c of f prime of x over g prime of x. So basically what we're going to do when we get to apply L'Hopital's rule, we'll basically just take the derivative of the numerator and the derivative of the denominator to see if that makes it easier for us to take our limit. The biggest thing I do want to point out is L'Hopital's rule can only be applied to limits which give indeterminate forms. So we can't just take the derivative of the numerator and derivative of the denominator and find the limit, because you'll find that this is a pretty easy process to do, but we can only do that if, when I first of all do direct substitution, I get 0 over 0 or infinity over infinity. Alrighty, let's try some examples. First of all, we're going to find the limit as x approaches 0 of e to the 2x minus 1 over x. So if we try to plug 0 in, I'll plug 0 in here. I end up getting 1 minus 1 over 0, and that gives me 0 over 0. And so we have gotten an indeterminate form. Last year I would have shown you a different thing. We would have tried to do, again, factoring. We would have tried to do multiplying by the conjugate, and really nothing fits for this one. So we get to use L'Hopital's rule, which I think you'll end up liking. All right, so what we are going to do, we're going to find the limit as x approaches 0 still, but this time we're going to take and I usually like to put LR next to this when I'm actually applying L'Hopital's rule to let the person who's reading my paper know that I'm applying L'Hopital's rule. Okay, so now we're going to take the derivative of the numerator, which is going to be 2e to the 2x, and then we're going to take the derivative of the denominator, which will be 1. And now notice when I do that, the reason that I did that is because now still I want to be able to plug in 0. And so when I plug in 0, I actually end up just getting 2 over 1, which is 2. So my limit is 2. Simple as that. Okay, example 2, I have the limit as x approaches infinity of ln x over x. So the first thing that I want to do is just go ahead and plug in infinity for both my x's. The natural log of infinity is going to be infinity, and obviously down below we have infinity. And so since I have infinity over infinity, that doesn't mean that there's not a limit. It just means that I can't I need to find some other way to do it. So since I got an indeterminate form, we can apply L'Hopital's rule. So we'll find the limit as x approaches infinity again, but this time we get to take the derivative of the numerator and of the denominator. The derivative of the numerator would be 1 over x, and the derivative of the denominator would be 1, so I'm simply just left with 1 over x. And this time if I plug in infinity, I get 1 over infinity, and 1 over a really large number is 0. So the limit of this problem would be 0. All right, problem 3. The limit as x approaches 1 of ln x over x squared minus 1. Again, the first thing that I want to do is plug in 1 for my x's. When I do that, the natural log of 1, hopefully you remember, is 0. And down below, 1 squared minus 1 is also 0. So I've ended up with an indeterminate form, which means L'Hopital's rule, here I come. So what I can do is take the derivative of the numerator, which would be 1 over x, and then I'll take the derivative of the denominator, which will be 2x. And what I'm going to do from here, there's a couple things that I could do from here. I guess I'll go ahead and just plug in 1. If I plugged in 1, I get 1 over 1 divided by 2 times 1, which gives me 1 over 2. So my limit would be 1 over 2. If you wanted to simplify this first, I could have done 1 over x times 1 over 2x. That would have given me 1 over 2x squared, and then I could have plugged in 1. Evidently that was not necessary in this problem because we could just plug stuff in. So my limit is 1/2. Whoops, and I should have put LR to let my reader know that I'm applying L'Hopital's rule. All right, let's try another one. I have x squared, the limit as x approaches negative infinity, over x squared over e to the negative x. So I'm going to have negative infinity, that's a crazy looking infinity sign, over e to the negative infinity, which turns to positive. And so negative infinity squared is just infinity. And then e to the infinity is infinity. So fortunately, I ended up with an indeterminate form, which means I get to apply L'Hopital's rule. So L'Hopital's rule, here we come once again. So I'm going to find the limit as x approaches negative infinity. Taking the derivative of the numerator is going to be 2x. And then taking the derivative of the denominator is going to be negative e to the negative x. Now again, if I plug in infinity, negative infinity, I'll get 2 times negative infinity over negative e to the negative infinity. So this is going to be negative infinity up top, and then down below I actually get negative infinity on the bottom, which turns out to be infinity over infinity. So I actually didn't get another answer again, but I did get an indeterminate form, which means I can do L'Hopital's rule once again. So I'll take the limit as x approaches negative infinity. So now I get to take where I was at before. The derivative of 2x is 2, and the derivative of negative e to the negative x would be e to the negative x. All right, and once again, I'm going to be plugging in negative infinity. So I'll get 2 over e to the negative infinity, which just gives me 2 over e to the infinity. Since e to the infinity is infinity, 2 divided by infinity is 0. So my limit of that problem is 0. All right, the limit as x approaches infinity of e to the negative x over the square root of x. Well, you can look at this one. It's not set up like the other ones because it's not a fraction. So what I'm going to do first, since I know that it's in L'Hopital's rule section, is actually make it a fraction. So I'm going to move this down to the denominator. So I'm going to turn this into the limit as x approaches infinity of the square root of x over e to the x. All right, now let's go ahead and try to plug in infinity. I'll get the square root of infinity over e to the infinity. That gives me infinity over infinity, which is an indeterminate form, which means that I'm allowed to use L'Hopital's rule. So if I'm using L'Hopital's rule, I'll get the limit as x approaches infinity. The derivative of the numerator, remember this is x to the 1/2, would be 1/2 x to the negative 1/2. And then in the denominator, I'm going to get the derivative of e to the x is e to the x. So let me see if I can rewrite this. This is now going to be 1 over 2 squared of x over e to the x, and then let's see if I plug in infinity, I'm going to get 1 over 2 times the square root of infinity over e to the infinity, sorry about that, and then 1 over 2 times the square root of infinity will be 0, and then e to the infinity will be infinity, so 0 over any number is just going to be 0, so my limit is once again 0. So hopefully now you're somewhat familiar with using L'Hopital's rule to find the limit if you have an indeterminate form.